In the right light, to get some of the ones where you have a X-ray diffraction, I don't see any up here, but you can get beautiful colors because there you go, beautiful colors because they are really little glass shells, very delicate glass shells.
Snowflake.
Right? They look like. I love these because they're just, you don't see them. They're very often just mixed up in sediments. There's people who specialize in these. And make a lot of money because they're very valuable for what's called biostratigraphy. In other words, identifying rock layers based on the fossils present in them. So because they're so unique and so diverse, but most people aren't aware of them, even though they're a huge part of the oceans and the ecosystem in our geologic record. Anybody have questions before we keep going? Crazy glass shells. So we covered crazy glass shells. We covered all the types of sedimentary rock and igneous rocks. What do you think we're going to cover next? Metamorphic rock. And you sound so enthused. So. Metamorphic. Okay, so, but I counted 6 instead of 7 letters and needed Lindsay's help to figure that out. So we're all doing well this Monday. So physical and chemical weathering provide the raw. Let's get this last blank filled. All sedimentary rocks, and then let's go on to metamorphic. Now, what is a metamorphic rock? It is a rock that has undergone metamorphism. So I'm not going to deduct points if this happens. I will giggle because it happens all the time. Rocks undergo metamorphism. That's the change from one rock type to another due to heat and pressure. Butterflies undergo metamorphosis. Okay, so try to keep those straight, or I won't deduct points on the test if you use metamorphosis instead of metamorphism, but I will giggle because that's what butterflies do. Is metamorphism or metamorphosis. So what is metamorphism? Solid state alteration of a protolith. Oh my gosh, that sounds like a really scary definition, and that's the kind of definition you get in a lot of geology. I copy pasted that from a geology textbook. So good question is, what the heck does that mean? So let's start off here. A protolith is a pre-existing rock. So to help us remember that word a little bit better, let's break it into its stems. Have we gone over what lith means? I don't remember. Rock, yeah, perfect, Caitlin. So it was a long time ago if we went over it. So lith means rock. What does proto mean? Original or early. So a protolith is just a rock before it goes through metamorphism. It's the first stage. What do you think we mean by solid state?
Changes without melting.
No melting. What do you think we mean by alteration?
Melting.
What do we mean if we alter our clothes? What do we mean?
Change.
Excellent. So basically what we're saying is changes to pre-existing rock without melting. Ooh, it helps if my handwriting is a little bit better than that.
If we need to go back to vacation.
Go what? On vacation? I am glad to be back at work, honestly. I really like my job. And you can't go hiking. Well, I do hike in the winter, but not as much. Right? There you go. Cold shouldn't scare us. Okay. So metamorphism can alter any rock type, including sedimentary, igneous, and metamorphic. Huh?
Should pencil come in colors?
Come in colors? This one.
No, it changes. It's like a heat thing. Oh
Is it?
Yeah.
Do I have a
light on
hypercolor?
it changes.
Well, I'll be a monkey's uncle. There you go.
And you thought you had the bad
That's
pencil
cool.
I did. I didn't realize I had, and it's Scanlon. So go get tutoring, right?
Yeah.
You know, they're awesome. So, so let's take a look at a couple of examples of that. And I think those are mostly on the back table over here. I've been passing them around. We got that, and then let's do this series. This guy, and so an example of how this change can happen. So we'll start off with a dark sedimentary rock like this guy right here. And what was the name of this dark sedimentary rock? Smooth, dark, clastic. You're thinking of the igneous rock that looks super similar. Begins with an S.
Shale.
Shale. Excellent, Amber. So we've got shale. We apply heat and pressure to the shale, and we end up with this metamorphic rock that you can write on. I demonstrated it to the other class. It used to be used for chalkboards.
Slate.
Slate. Excellent. So we go heat and pressure. Now this can undergo even more heat and pressure and change further into this. Ooh. Shiny disco rock. So this shiny disco rock is known as a mica schist. Holy schist, it's a schist. Okay. Get ready. Now that you understand the rock puns, you'll be catching them more and hearing them more. So we can see that as we increase in heat and pressure, we can even transform metamorphic rocks into other metamorphic rocks. So we can start off with a sedimentary rock like shale, add some heat and pressure, and become a slate, and add even more heat and pressure, and become a schist. And you don't have to memorize this sequence, but except it might show up on an extra credit, blah blah blah. So yeah, did you like now? So you do have to memorize it. It's 3 points. So I'm saying if you have a hard time memorizing all the little random stuff, focus on the core stuff. That's what I always mean.
Oh, this rocks my world.
Awesome. Nice.
Come up with all
Anyways, you'll get that one in a few moments. So, metamorphic changes are due to variations in temperature and pressure, and these are often caused by tectonic stresses. Caused by tectonic stresses. And different kinds of rocks will form in the presence or absence of water. So there's some minerals like hornblende that you're not going to see, like we'd see in a serpentinite, that you're not going to see if you don't have water involved. And they talked about that a little, mentioned that very briefly in the video that we watched on the snow day. Okay? So, in metamorphic rocks, the temperature change does not result in melting. And metamorphic changes can, although don't always, result in changes in mineralogy. How bad is my hair? Is it sticking up? Oh, okay. So, you recognize this guy now. What's this one?
Sandstone.
That is a sandstone. It is a red sandstone. Red sandstone, as we talked about. Ooh, red stone? Red sandstone is what I meant. I got so excited. Sandstone. Has quartz, clay, and iron oxide. Now this is the rock, this is a sedimentary rock before it goes metamorphism. So what are we going to call this rock? This rock. This is the protolith. Excellent. Now, after heat and pressure, it can turn into this, which is a mixture of quartz feldspar, biotite, which is a form of mica, which is why it's all glittery. And then if you look at this, it looks a little bit like raisins in an oatmeal cookie. Those are garnets. Okay? Isn't that, ooh. So they're very low quality, so don't be like, I'm stealing garnets by putting it in, I mean, you would technically be stealing garnets, but you're not going to make any money off of this. So, this is what's known as a garnet gneiss.
Yeah, it's G-N.
It's G-N-E-I-S-S. Nice.
Uh-huh.
And that's the one I'm always saying in my head when I'm like, nice. So you can go ahead and pass that around. Now, two important metamorphic rocks in this area, the two that you will find around here. The two big common ones are marble and gneiss.
That's nice.
Well, it's not nice. It's not nice to take schist for granted.
Wow. Rock fun.
I am full of rock puns. You're gonna get so sick of them. A nice big hunk of marble.
Juicy and stuff.
But I can grab another one from the drawer. Okay, so. So the gneiss around here is this kind of banded gneiss that looks like this. It can come in a variety of different colors. Not all of them are pink and black. A lot of them have big bands of white quartz also running through them, particularly in this area. So let me grab this sample right here. It's got these stripes in it. The stripes are known as foliation, or the bands, and they can tell you the direction that the pressure was, okay? So you'll find a lot of this, particularly to the north, when you get up towards A-Bay, Redwood, that whole area in there. Do you have a question, Parker?
The road my grandmother used to live on in Lake Placid was always covered in quartz
It was always covered in quartz.
because of where they blasted to put the road, probably.
So my guess is that that wasn't quartz, because you wouldn't, there's nowhere around here where you could blast and just get huge quantities of aggregate quartz. But I would be interested in seeing a sample of it so we could identify what it's probably made out of.
Yeah, I would have to go back up and get a sample. And she
Yeah.
lives down in Dexter, you know.
Down in Dexter, oh well, yeah. So if you happen to have a sample you find around the house, and that goes for everyone, this is the unit. Bring in your rocks. We will explore that. We will answer questions about them. So, they're protoliths now. So, gneiss has many protoliths. It has many protoliths. But in this area, gneiss formed from granite during the continental collision that formed the supercontinent. Anyone know the name of a supercontinent?
Pangea.
It's not Pangea, actually. It's an earlier supercontinent that's even more awesome because it's hugely shaped. New York State formed the supercontinent Rodinia.
Nobody knows that.
Oh, can you not see that?
No.
There you go. So we do have evidence from Pangea, but it's in the southern portion of the state. This whole state, if you dig down deep enough, you will find evidence of Rodinia. Rodinia is a massive continental collision that occurred a little over 1 billion years ago, formed a mountain range bigger than the Himalayas from like way north of A-Bay all the way through here, all the way down south of here at Syracuse was a mountain range taller than the Himalayas. And if you go up to A-Bay and you see these bands of gneiss, what you're looking at is originally we had the mountain, and then what happens to the mountain over time?
It wears down.
It wears down. What's that wearing down called? And
Erosion.
erosion, excellent. Weathering and erosion eliminated it. So when you're standing here where you see these bands of gneiss and abe, you're standing on what used to be underneath at the bottom of an enormous mountain range. Did you have a question, Lindsay?
Can I have this rock?
Can you have that rock? Which rock is it?
The pretty one.
The pretty, oh, I don't have a whole lot of mica schist. If you said nice, I have lots of nice, but, because I can just go get more up in abe. Yeah,
What is that form? The what?
superconsonants.
Supercontinent.
Yeah, that's really poorly. I'll write it out clear. Super. There you go. That's what that should say. So the other one is marble. Marble has exactly one protolith, and we mentioned it in passing before. Did anyone catch it? It's the
What?
protolith. Yes.
I just have a question.
Veronica, what?
About the Rodinia, is Rodinia and Pangea two separate theories?
They're not two separate theories. They're two superconsonants that both existed. One is much older. So Pangea is only happened about 250 million years ago, whereas Rodinia occurred a little over 1 billion years ago. So it is a very old supercontinent. It's one of the earliest supercontinents that we have really, really, really good evidence for. But all the just like with Pangea, all the continents slammed into each other and made one huge continent. So marble has one protolith. Did anyone catch it? Kendall.
Limestone?
Perfect. Now, how might I prove that this marble came from the same source as limestone?
Both have calcium.
It's got the presence of calcite. And if I put acid on the marble, I see the bubbles, and that tells me that the calcite is present. Make sense? Awesome. I'm going to pass around these chunks of rock. Now, a fair and honest question. I am a geo major. To me, I'm like, more rocks is more better. However, I am glad that there are all sorts of other majors in the world because I need things like accounting. Someone else does my taxes. I need things like medical assistance and all that kind of stuff. So, if you are not a geologist, your question might reasonably be, which rocks what? One question you might reasonably have as a student is about the rocks is, which rocks what?
Might be on the test.
Might be on the test. Excellent, Abigail. Practical thought here. So for some reason the title showed up over here, so we're going to put everything on the top here. Put rock on this column, type, description, and minerals. And we're not going to fill in all 3 of these for every single sample. Only thing we're going to fill up for all of them is rock and type. If it's on this chart, you need it for the test. If it's not on this chart, you can relax a little bit, okay? So, let's start with the rock basalt. What kind of rock is basalt?
Igneous.
Igneous, excellent. What kind of igneous?
Extrusive.
Excellent, extrusive igneous. Okay, what does it look like? It's black, it's a dark color. Now, you don't need to know this for the test because we don't go over the mineral pyroxene, but basalt is almost purely this mineral called pyroxene. It's very metal rich. But once again, because I'm not going to test you on it, just know it does have minerals, but you don't have to memorize which minerals it has. Now, another rock type, granite. What is granite? We did just do it. Huh?
Intrusive igneous.
Intrusive igneous, excellent, Abigail. So intrusive igneous, I'm just going to abbreviate it that way. Oh, for basalt, we need to have black small crystals. And it definitely has minerals because it does have crystals. And then intrusive igneous, Granite, how would you describe it? Large crystals. And since granite is so important for everything else, I want you to know the minerals in it. And the minerals are quartz, feldspar, and mica. Those are the three big minerals that we find in granite. So, obsidian, what type of rock is obsidian? Extrusive? Igneous, excellent. Extrusive igneous. How would you describe it? Glassy, excellent. It can actually come in a huge range of colors. I have some of those colors back here. So if anybody's curious, here's some green obsidian and some red obsidian. Right? Aren't they funky? Right? Jolly, jolly obsidian. Okay, so it's glassy. So what minerals does it have? None. Excellent. Pumice. What kind of rock is pumice? Igneous. What kind? Extrusive igneous. Excellent. How would you describe it? It has what? Bubbles. It's got the bubbles in it. Once again, the technical name for those bubbles is vesicles, and it's called vesicular. But I'm not gonna, maybe an extra credit. What's this technical name for it? It has bubbles. So what minerals does it have?
It's heavy.
None.
None. No minerals. And I think we got time for maybe a couple more. Let's go over what kind of rock is coal?
What? Oh. Sedimentary.
Sedimentary. What kind of sedimentary? Organic. Excellent. So it's an organic sedimentary. How would you describe it? Black. What minerals does it have?
Dead leaves.
No.
Parker says none. What made you say none, Parker?
Because it's primarily plants.
Because it's organic. Excellent. So it is another of the none. So on the test, there will be questions phrased like, which rock has no minerals? Or it might say, give me an example of a rock that has no minerals. One of the wrong answers will be, all rocks have minerals. Will you fall for that wrong answer on the exam? You will not fall for that wrong answer. Excellent. We will finish up this rock list on ones you have to focus on, and then go into earthquakes on Wednesday. The extra credit is still happening at 12:30 on Tuesday as of right now. Do keep an eye open for Blackboard, because I might have a couple of urgent meetings this week. And I will see you all on Wednesday. I love that umbrella. That is so cute.